Hi, my name is Kate Schutz, and today I'll be presenting the results from my Lab 1 experiment. In this presentation, I'll be giving a short introduction of the experiment, then I'll talk about the data, observations, the code I wrote, and finally the results and conclusion of the experiment. The purpose of this lab was to determine the charge of a piece of tape and the magnitude and directions of the forces acting on it. The fundamental principles used in this experiment were Newton's second law, the Coulomb force law, and the principle of how electric fields are caused by point charges. I used three equations, one for the electric field, one for the forces of the electric field, and one for the force of gravity. In this experiment, I created two charged pieces of tape by sticking two pieces of tape together and then tearing them apart. I did this twice to create two pieces of tape with the same charge sign. I then found the sign of each two charged tapes by putting a known negatively charged object near the tape and used Coulomb's law, which states two opposite charges attract and two like charges repel. In this experiment, the negatively charged object was a plastic pen that I rubbed into my hair to give it a negative charge. When I placed the pen near the tape was attracted to the pen. Therefore, I found the tape to be positively charged. Next, I connected each one of the charged tapes onto two different books. The tape formed a bridge-like connection between the two books. Then I brought the second charged tape near the first tape and watched as the second tape made the first tape float. I brought it underneath it and it made it float due to repulsive forces, and measured the distance between the two tapes. The distance was 3.2 centimeters or 0.032 meters. And then the next thing I did was use a computational model to calculate the gravitational force and an electric force on the top floating tape. Here are my data and observations. Like I said before, I found the U tape is positively charged. I also measured the length of the tape, which I found to be 8 centimeters or 0.08 meters. I then found the mass of the tape by using the conversion that every meter of tape equals 1 gram of tape. I used this to find the tape mass to equal 8 times 10 to the negative 5th kilograms. I then found the magnitude of the force of gravity by multiplying the mass by the gravitational constant, and then I found the floating tape is in equilibrium. Then, because it's not moving, and so that's an assumption I'm making that it's in equilibrium, and this means that the magnitude of the gravitational force equals the magnitude of the electric force. I then found the charge of the floating tape by setting these two equations equal to each other and then solving for Q. The last thing I did was I calculated the magnitude of the force of the electric field by using Coulomb's law. I then created a computational model to show my calculations. This model was distinctly different from the model I created in Lab 1 because instead of representing the force of charged tapes as one particle, I represented each tape as a line of charged particles and calculated the effect of each of the charged particles from the bottom tape and the effect they had on the top tape. So first I defined a few variables. Pez is a constant I will use later when calculating the electric field. G is the gravitational constant, and M is the mass. I also have Q defined here, which is the estimated net charge on one tape. I started Q off at the charge negative 1.6 times 10 to the negative 19th, and then change this value later. I'll discuss more about that at the end of my presentation. Second, I created a function for the calculation of the electric field using the formula I mentioned earlier. This function in my code creates a line of, and then the next thing I did was I created a function that creates a line of n uniform point charges with a given total charge and mass arranged at equal intervals on a line segment, starting at a position and extending along an axis. So basically, this is going to be a line of circles, 10 circles that each represent a particle, charged particle. So then the next thing I did was I created two objects to represent the two tapes, with each tape modeled as a collection of point charges placed side by side in a line. I made the y components of the tape equal to the distance I measured between the tapes during the experiment, which is 0.032 meters. Then fourth, down here at line 100, you can see I have an e-scale variable. More on that later, but basically I scaled each of the arrows to make the computational model look nicer. So the fourth thing I did was I calculated the electric force on the floating tape, or top tape, due to the force from the bottom tape. I did this by adding up the forces from each separate charge of the bottom tape as they interact with each particle on the top tape. I ignore any interactions between the particles within each separate tape. And then I also created an arrow for the electric force that acts upon the top tape charges. Fifth, I created two arrows to represent the electric force and the gravitational force. I then scaled these values using the variables I created earlier, FE scale and FG scale, to create a computational model that looks good. As you can see, those are on lines 109 and 110. Sixth, I then printed the magnitude of the electric field, the electric force, and the gravitational force. And here's my computational model. After I calculated the magnitude of the electric force and magnitude of the gravitational force, I then adjusted the value of Q to make these values equal. Then I scaled the arrows to make everything look proportional, like you can see here. So, basically my results are that I calculated the magnitude of the charge of Q, and as well as the force of gravity and the force of the electric field, and created a computational model that looks like this. And the assumptions I made were that the U tape had the same amount of charge that was evenly distributed along the tape. Thank you.